Now let's put everything together to see how to find the absolute maximum and minimum of a continuous function on a closed interval. So, the first thing you're going to do is to find the critical points of your function f. And remember, that means you want to find the places where the derivative is 0 or sometimes undefined. The critical points are the only places that you might have local maxes and mins. And now what you're going to do is to build a table so you can take a bunch of different x values. You're always going to try a and b, which were the two endpoints. And then you're also going to try any of the critical points that are in your interval. So maybe let me call them C1, C2, and so on. You're going to take all of those values and plug them into the function f. So f of a, f of b, and so on. And then simply the highest output is the absolute maximum, and the lowest is the absolute minimum. Well, let's just illustrate that with an example. So let's find the absolute maximum and minimum of the function f of x equal to 4x cubed minus 9x squared on the interval from 0 to 3. So first we want to find the critical points. We'll take the derivative of f, which in this case is 12x squared minus 18x. Since that's defined everywhere, we'll just set it equal to 0 and solve. Both terms have a factor of 6x in them, and if I factor that out, I get 6x times the quantity, 2x minus 3. And so we get two solutions. Either x is 0, or if 2x minus 3 is 0, that means that x is 3 halves. And for all of your critical points, you want to check and make sure they're actually in your interval. And indeed, these are both in the interval 0 to 3. Now, we just want to take the critical points and the end points and plug them into the function f. Well, in this case, one of the critical points actually was one of the end points. That can sometimes happen. So I have to test x equals 0, and x equals 1.5, and x equals 3. And remember, you're plugging these not into the derivative, but into the original function, 4x cubed minus 9x squared. Using a calculator, you'll find that f of 0 is 0, f of 1.5 is negative 6.75, and f of 3 is 27. So 27 is the highest output. That represents your absolute maximum. And negative 6.75 is your lowest output. So that represents your absolute minimum. Then if you were to look at the graph of this, what you would see is that the graph kind of dips down below the x-axis and then increases like this. We're stopping the graph here at x equals 3, so this is that point 327. And that's the local minimum, which happened at an x value of 1.5. So that's the point 1.5, comma, negative 6.75. And so the absolute minimum occurred at this local minimum that was in the middle, whereas the absolute maximum occurred at this end point right here. Okay, so using this basic technique, you can find the absolute maximum and minimum of any continuous function on a closed interval. The hardest part actually is finding the critical points, because depending on what f is and what f prime is, well, setting that equal to 0 and solving can sometimes prove kind of difficult.